All right, so this is our unit on word problems, and so I'm going to kind of talk you through the first two learning targets of the unit. So it's all about modeling word problems through equations. So just keep that in mind. The first learning target is I can model an expression, equation, or inequality based on a given mathematical statement. And the second one is I can translate a real-world situation about equal quantities into an equation and solve the problem. So before we get kind of going on that, you've already had some experience with word problems. So what we're going to do right now is kind of talk through vocab words. So if you look here, there's kind of some vocab words for addition, subtraction, multiplication, division, equal. So anytime you see, plus, sum, add, increase, total, more than, altogether, greater than, combined, or in all, that means addition. Anytime you see take away, minus, sum, difference, decrease, subtract, less than, that is subtraction. Multiplication, times, 2 of x, product, multiply, double, triple, twice. Those are all indication of multiplication. There's division, quotient, out of, fraction, over, split into, divide, of, half of, and grouped into. And equals is the same as, equivalent, or the word is. And that's the word is going to be a big indication in the ones we're going to look at in a minute. So if you're kind of stuck as to what kind of word problem you have, take a look at this. Use this as your reference. So I'm going to go over a couple examples with you, and then hopefully you can be successful on your own. So the first couple examples is just kind of writing out expressions given a word problem. So the first one says a number 5 more than x. So 5 more indicates I'm going to add 5 to whatever that number is. So I know that x is the number that they're giving me, so 5 more than x might look like x plus 5. You could write 5 plus x. Commutative property tells me that that is okay. A number twice as great as x. So twice, if you're thinking of like ages, so like say my age would be twice your age, then you would know to multiply by 2. So kind of think if you're stuck, simpler examples, so that would just be 2x. A number 12 less than x. So 12 less means I'm actually going to subtract 12 from whatever that number is. Sometimes students will do 12 minus x, but I'm actually taking 12 less, so I want to subtract 12. 4 times the difference of x minus 7. So this one is different because it talks about 4 times the difference. So if I want 4 times the difference, I'm going to say 4, but the difference I'm going to put in parentheses of x minus 7. So because it's 4 times the difference, it's 4 times the whole quantity of x minus 7. So you need parentheses there. Okay, so we're kind of a couple examples of how to model expressions based off of word problems. So I'm going to do a couple examples and actually solve. So it says, use an equation to model and find the number. 5 more than twice a number is 25. So the first thing I like to do is define what my x is. So because I don't know what the number is, I'm going to let x equal a number. So I know that x is a number. So 5 more than twice a number. So twice a number would be this, 2x. And then 5 more is plus 5. That is a huge indicator, that equal sign, 25. So when I have that, now I can solve, subtract 5 on both sides. I come over here, I get 2x equals 20, divide by 2, I get x equals 10. And so my number that I was trying to find is 10. You could probably find the number without doing the algebra, but a focus of this unit is to be able to model word problems with equations. So I really want you to try to challenge yourself to solve the problem using an equation. Okay, the next one, it says 6 less than 5 times a number is 29. So the first thing I'm going to do is define what my x is going to be. So x is going to be a number. That's the thing I don't know. So 6 less than 5 times. So I have 5 times that number, so 5x. 6 less, so that means I'm going to take away 6, is 29. So anytime you really see that is, that's an indication that you're going to have an equal sign there. So then if I go ahead and solve this, I can add 6 to both sides. I get 5x equals 29 plus 6 is 35. Divide by 5, and I get x equals 7. So that is the number. So this is kind of really what 2.1 and 2.2 is going to ask you. You're going to be taking like statements like this, setting up an equation, and solving for that missing number. So use these examples as a reference. Your practice is very similar. There might be one or two that are a little more challenging, but I think you guys can figure it out.